Welcome to Lecture 2 in the Beginner's Guide to Understanding Chemistry. We'll spend a lot of time in this lecture talking about the periodic table of elements. Although the periodic table can look quite daunting, it's actually organized in a very systematic way that helps us understand certain properties of the elements on the table. Each column going vertical is called a group. Atoms or elements in the same group have similar properties. Each row, horizontal, is called a period. Each element is assigned a number called its atomic number. This is the number in the upper left-hand side of the element box. For example, hydrogen in the upper left-hand corner has 1, and helium, if you go across in the upper left-hand corner, has a 2. This is known as the atomic number. Each element is also assigned an atomic mass. This is under the name of the element. For hydrogen, this is 1.008, and for helium, this is 4.003. This tells us, in a sense, how much that element's mass or weight is, measured in a tiny unit called an atomic mass unit. Based on the previous slide, you should be able to answer the following question. Furthermore, the periodic table is subdivided by this black line. Anything that exists to the left of this black line is known as a metal except for hydrogen. Hydrogen is not a metal. Everything else to the left of this line is a metal. Everything to the right of this line is a non-metal. And anything that falls on this line is known as a metalloid, like germanium and arsenic. These are both metalloids, which means they have properties of both metals and nonmetals, which is quite interesting. In group 1A is called the alkali metals. In group 2A is called the alkali earth metals. In this area, these are known as the transition metals. There's a whole field or class of chemistry that's devoted to this, and it's called inorganic chemistry. I will not be covering inorganic chemistry in this series. In group 7A, these are known as the halogens. We will be looking at the halogens a lot in this course. And in this group 8A are the noble gases. We will not be diving too deep into the noble gases, although we will see some examples of how noble gases behave. Cover some more on atoms. Atoms are incredibly tiny. They're about 10 to the negative 10th meters in diameter. Example is if the atoms in your body were increased to be 1 inch in diameter, you would bump your head into the moon. That's crazy. Even crazier, there are a massive number of atoms in even a small sample of an element. For example, in a 1/2 carat diamond, which is made up of a ginormous amount of carbon atoms. I don't know if ginormous is a real word or not. It has 5 times 10 to the 21st power atoms. If you took all of these atoms and lined them up in a straight line, they would reach the sun. Believe it or not, smaller particles exist inside of atoms. These are called subatomic particles. The first one is called the neutron. The neutron, also N, is located inside the atom's nucleus. It has no charge. Its mass is 1.00867 atomic mass units, or 1.6726 times 10 to the negative 24th grams. Because this unit is so tiny, we use these things called atomic mass units to denote their mass because the masses are incredibly small, as we just looked at with how heavy they are in grams. The next particle is the proton, or P. This is also located inside the atom's nucleus. This has a positive 1 charge. Its mass is 1.00728 AMU, which is almost the same as the mass of the neutron. And even smaller in terms of mass is the electron. The electron is located outside the atom's nucleus. It has a negative 1 charge. Its mass is 0.000549 atomic mass units. That thing is tiny. And the electron will be the subatomic particle that we actually study the most in chemistry. You tend to study things like protons and neutrons more in a field of physics. Let's put this into a picture. What do atoms look like? We said that in the nucleus of an atom exist protons, which are in red, and neutrons, which are in yellow. The proton has a positive charge, positive 1. The neutron has a neutral charge, or 0, no charge. Outside of the nucleus of the atom, we said exist even smaller subatomic particles called electrons. Electrons, which we'll get into, exist in defined regions of space called orbitals. The electron is the fundamental subatomic particle that we will actually study the most in this course of chemistry.